We have a really exciting panel today. The title is Intelligent Machines, AI, Autonomy and Robotics. So this is part of our physical AI theme, where we bring AI into the real world or into enterprise applications. And what I'd like to do is for the speakers to just briefly introduce themselves and tell us about your journey in AI and what you're most excited about today.
Okay, I'll go first. My name is Beena Amanat. I lead our global Deloitte AI Institute. Prior to this, I led AI at companies like GE, Thomson Reuters, Bank of America, a variety of industries before I joined Deloitte. At Deloitte, I focus on looking at the latest technology, the latest AI models that's coming out, and how do you apply it in a bank, in a factory, in a hospital, and what are the nuances that come with it. So I'm very focused on applied AI and research around it to really guide the AI application in the real world.
So what are you most excited about today?
I think I'm most excited about learning from all the leaders here and the speakers here and seeing what's happening in the tech space that then I can take to the real world in the applied space.
Fantastic. Thank you. Samir?
Good morning, everyone. Thank you for being here. It's a pleasure and an honor. I'm Samir Menon, founder CEO of a startup called Dexterity Inc. We work on helping robots get human-like skills with their hands. And so I did my PhD at Stanford, spent a good amount of time here. It's great to be back, even though we're just a few miles away. It's always a refreshing pleasure. I would say it's a very exciting time for AI. And when we think about AI, what we've seen over the past few years are these amazing language assistants that can talk with us, chat with us, converse with us, amazing processing capabilities when it comes to dealing with images, with text, now with video. And I would put all of that broadly under the bucket of what we would call digital AI. But under the covers, there's another category of work in AI that's been steadily making progress, and we call it physical AI, in contrast to digital AI, because it involves touching, feeling the physical world. And so we're still very early days of having robots have human-like skills, but we've seen phenomenal progress over the past 5 years or so. It's a really exciting time for us. I'd welcome you to come check out some cool robots that we have on our website, and happy to talk about it today.
Great, thank you. Steve?
Thanks, nice to be here, everybody. My name's Steve Cousins, and I'm the executive director of the Stanford Robotics Center. I just came back to Stanford a couple of years ago after stints in research labs and then running a think tank called Willow Garage, where we created the robot operating system. And after that, I did a startup for a few years trying to put robots into the service industry. So I've been on the front lines of trying to put robots out there and also in the kind of think tank world. And it's great to be back at Stanford and see the changes that Samir mentioned. We've had, 15 years ago, we were building robots and working hard on perception, but not making a whole lot of progress. And then there's a breakthrough, which was basically AI image understanding. And almost at the same time, or shortly thereafter, you have robots that you can, or computers that you can talk to. You have Amazon Alexa doing far-field speech. And so suddenly, in a relatively short period of time, you go from, we can build robots that can perceive their world sort of and do something over and over, to robots you can talk to that can, with zero shot, tell you what they're seeing. And that really opens up interesting worlds. So I'm excited about both the dexterity, I'm excited about the capabilities that we're going to have in manufacturing to really take that to a new level. And I'm also excited about the possibility of taking robots out of constrained environments into real human environments and being able to operate there successfully. So yeah, I'm glad to be here.
Great. Karen?
Hi, my name is Karen Liu. I am a professor in the computer science department at Stanford. I started as a researcher doing computer graphics, had nothing to do with robotics, definitely nothing to do with AI. But over the years, we started, developing a lot of physics simulation, physics engine to to help us creating character animation. And after a while, we realized that a lot of things that we're doing with the simulation, with the control, with the motor control, optimal control reinforcement learning, it has no difference to robotics, a lot of things that robotics people are doing. And that's when we start looking into the possibility of not just making our character animation realistic, but the possibility of making our character animation real. And with the humanoids today, this is something that we see that our vision start to become reality. And that's what I'm really excited about nowadays.
Fantastic, thank you. Okay, let me kick off with a question maybe to Samir and also Steve. Both of you have been deploying robots into real human environments and into warehouses, into messy scenarios that are not laboratories. You know, I remember a lot of, seeing funny videos of robots fail. You know, like what are some of the scenarios that you remember where you're like, oh, wow, I didn't anticipate this, something really, you know, a striking failure of something that you thought was gonna work out somehow?
Happy to share a few stories and some context for folks. When we think about physical AI, robots have been around for 50 some years now. They're very, very successful in places where you can precisely control the environment. So imagine a car manufacturing plant. Car comes along, robot can go weld it, drill holes, paint it. The car manufacturing plant manager won't let one screw be out of place. And because it's perfectly controlled, you can predict what is going to happen, which greatly simplifies the challenge. With robotics and physical AI, the crux of the problem that we face is when you enter uncertain environments, even though they might look very naive, they might look fairly straightforward, you encounter substantial complexities and variations. And I have a couple of very interesting stories just to make this point. For us, manufacturing would be what we would call ground zero. Robots work pretty well there. A significant step up is logistics. You get out of the manufacturing plant, boom. Your precision's gone, your predictability is gone. Everything's different. You have these parcels like tumbling around, mixing with each other. Somebody shipping from Europe, somebody shipping from the US. So we have our robots in these somewhat chaotic, but at the same time critical to our society warehouses sorting packages. And it goes great. Most of the packages are some small boxes. Some of them are these poly bags full of books and clothes. And once in a while, you get an odd one. And so I'll pull out two that I found, which were literally, I think, smacked us in the arm. One was we were sorting a small parcel sort. And these are supposed to be small parcels, 8 pounds or less. Robot's like pretty good. It's learned how to do its stuff. And there's this little conveyor belt like feeding parcels to the robot. And we get a call, hey, your robot broke. And I was like, okay, what happened? It just like broke. I was like, what do you mean it broke? It like broke into pieces. It's like, that's strange. That really shouldn't happen. And we had a little video camera there, and the small parcel sort, we saw magically at one point in time there was this robot, and then this anvil, like a blacksmith's anvil, came tumbling down. There's like little packs of books and children's clothes, and poof, smacked into the robot and broke it. So we find things that are pretty extreme like that. But there's some stuff which is also pretty funny. There was one time when we were doing small parcel sort, and I learned that it is possible for us to ship live earthworms in a small parcel. And they get sorted in the sorter system. And I was very surprised to hear that. But how we found out was these live earthworms have to breathe. And for them to breathe, there are these little holes in this box that they're in. And our robot used these kind of vacuum suction type of grippers. It's kind of like an octopus hand. And so, hey, your robot hand's not working. It's like, what's going on? And we eventually found out that there was a good amount of earthworm juice in the hand. So I think the challenge with physical AI is we take our intelligence for granted. We have an amazing amount of intelligence in dealing with things that are pretty simple.
Steve, you mentioned zero shot. I'm not sure if everybody understands what that means. Can you maybe just briefly explain that? And tell us why that is a pivotal moment in time, how the past didn't have zero shot, and this might be an enabling factor?
Well, yeah, if you usually we program, like when we designed the relay robot to deliver in hotels, we spent a lot of time scripting the interaction you'll have at the guest room door. And it worked because we ended up writing a really good script and people liked it and you can see, videos. But that's a one-time script. If you want to send the robot onto some new task that you've never done before and you want to just give it an instruction and say, go do this, the question is, can it actually respond in real time? And the AI gives us the possibility of telling it to do something. And Google has this nice demo where you basically walk up and talk to a pair of robot arms and you tell them what you want them to do, and it just does whatever you said, right? There's nobody programmed it. This is the first time anyone's ever said, open the drawer and flip it over, or whatever you said, right? And so that's kind of zero shot. Now, the caution that I want to make sure we all understand is there is a safety thing going on, right? When we were in factories, you're behind safety cages for a long time, or we're very, very careful to control the environment. Logistics environments, you can make everybody wear steel-toed boots and you can keep them behind the yellow lines. When you go into the real world, you don't have that anymore. So we put our robot into a hotel for the first time, and the very first time we looked through the cameras to see what the robot was seeing, we saw barefoot 3-year-old toes. In other words, a 3-year-old came up and hugged our robot, right? And we're like, whoa, we weren't thinking about this when we designed the safety systems. You have to make the robot safe for whatever people are going to do around them. And it has to be inherently safe. So we can have zero-shot AI, but we also can't guarantee that the robot's going to do the right thing. If AI has been known to hallucinate. And so we have to make sure that at a lower level, at a hardware level, that we've thought about safety, we've put the safeties in place, so that the robot can try to do whatever it thinks you said and have a good chance to do a zero-shot success. But you can't do that if possibility is I'll just knock Samir's head off, right? That's not okay. And so you have to really think about, you got to think about what could go wrong. And when that doesn't happen, you get, unfortunate situations. The first robot long time ago, 30 years ago, that went into Stanford Hospital ended up at the bottom of the stairs, right? That's never okay. There was not another robot in Stanford Hospital for 20 years after that. So you have to pay attention to safety.
Great. So a lot of the robots like PR2 and also the dexterity robot, if I'm not mistaken, have like a wheeled base, right? But over the last year, we've seen the emergence of these humanoid robots that start moving. Karen, you've done pioneering work in physics-based modeling of human movements, and you've been working on this for many years in computer graphics, simulating it, and now also bringing it to the physical world. How do you see robots actually transitioning from just barely moving to moving intelligently and enabling these zero-shot capabilities just from a movement perspective?
Yeah, it's a very interesting question. I will argue that when you talk about humanoids, like complex robotic systems, any movements require some level of intelligence. Like simple things like a humanoid walking forward for 3 steps, it's not that as simple as you think, because if you are a humanoid, how would you do that? You had to think about how much torque I need to exert to my hip joint, my ankle joint, my knee joints, so that when they coordinated, executing in the real world, they will give me enough of a force that push the ground, that gives me enough of a force to move forward. So that, to us, is very easy to do, but it is intelligence, right? Like if you think about system 1, system 2, this is the kind of intelligence that people don't think a lot about in system 1. And in short, this is definitely lower level than kind of intelligence we're used to with the ChatGPT. But I will argue that this level of intelligence might be even harder to learn from because we don't have a lot of data. Right? When people in you probably heard roboticists complain how little data we have comparing to language, comparing to text, comparing to images. But when it comes to humanoids with local motion, we have no data at all. And that is why we have to start with something, right? We start with a physics simulation. We start with what we know about motor control. We start with reinforcement learning so we can learn from trial and errors. But in computer graphics, we also know like if you just learn from trial and error, it would take a long time. So one thing that we can really utilize is the human motion. We can motion capture the 3D movements, and that's a lot of things that we see in video games and movies. Those data become so valuable now to teach humanoids, because if you want to start with reinforcement, you start with no data, but human data is not exactly the same as a robot data, humanoid data, but it carries a lot of useful information that help you to jumpstart your learning process.
Fantastic. I'm going to get back to the data question in a second, but before that, I just have a question for Bina. So intelligent machines are increasingly present in today's enterprises, influencing everything from daily operations to long-term strategy. Their capabilities are evolving rapidly, prompting leaders to rethink traditional approaches to innovation. From your purview, how is AI, automation, and robotics impacting organizations today?
So, just based on this conversation, I can tell you I feel so old because, a long time ago, before it was called physical AI, it was a world of IoT and data science. And we were looking at, more from a digital AI perspective, probably, which is what we call it today, is predicting. I was working on predicting jet engine failure or predicting how much a wind turbine can generate. And I remember, as Samir was describing his work, I remember distinctly, we were rethinking of, we could predict when a jet engine will fail and proactively send the field service engineer to go fix it so that you prevent flight delays, right? Simple enough. And then, what's the next step over there? How can you prevent, having to send a field service engineer, because that would take the longest time. So we actually had put together a business case for, having these automatic drones or some kind of robotic arms embedded within the jet engine that would, if it was a simple scratch on a blade of a jet engine, could this 3D print or manufacture something that could fix it on the fly while the plane was flying? This was the imagination part, right? And that's where something like dexterity comes in. And being able to, for me, physical AI means beyond just robots, the way we envision it, like humanoids. I think it's those small things of being able to do things faster, and the shape or form of it can be very different, right? And it really depends on the use case and in what scenario you're operating. Another use case, staying aligned to that. So this was, how can we make jet engines fix themselves by using robotics and AI so that you don't have to send a field service engineer? And then you take a step back and think about, why do jet engines exist for mass transportation? To get a group of people from point A to point B in the fastest possible, most optimized, cheapest way. Does that need to be there, right? Can we just have, in the world where you can call car as a service, using drones for delivery, why can't there be a drone that I can call right now that lands there, takes me from here to New York in my own individual space, right? I think, there's a lot that robotics can do, and many organizations are beginning to think of it beyond just that, just manufacturing or just warehousing logistics. Those are the beginning stages, but there's a lot of work being done, and this was from 2013, 2014 I'm talking about, but of course the technology was not there, the digital capabilities were not there, and companies like Dexterity didn't exist, right? So I think with the advances, these are use cases that become real, and I'm a huge believer that look at those applied AI phases where physical AI still has a huge presence, will have a huge presence beyond just manufacturing and logistics.
All right, thank you. So maybe, one hypothesis is why is now a good time for robotics is that we have generative AI now that enables these zero-shot capabilities of a robot being able to interact in an unknown environment that's not scripted. But generative AI is also very data hungry. So, we've seen great successes for things like, language, images, video generation, like many of you have probably seen Google Veo or other things. Like I think where we have infinite amount of training data, we can train these models, but oftentimes I hear people say, hey, we don't have that data for robotics. That's the biggest bottleneck. but we do have a lot of data for humans. So, we can look at videos, we can look at images, we can look at mocap data, just going back to Karen's point on movements. Are we going to see humanoid robots, which seem like a distant thing in the future, actually become successful sooner than other robots because we can learn from humans? Or, where do we have data? Where don't we have data? Why can't we build humanoid robots and learn from humans?
Question for me? Yeah, I'm not sure if you can, still on, okay. I certainly hope so. I think we definitely have the advantage of having humanoids being more similar to our own morphologies, then we can really use the data that we generate. Like right now, we're generating data to train the robots, to train humanoids. But there are so many different levels of a training, right? The part that I was talking about, this very low level, just being able to have ability ability of locomotion. And then there is an ability of manipulation, right? So in that case, you're not just capturing the data of the human itself, but this entire world. So I think I want to say that being able to collect data is one thing, but being able to simulate the world in a realistic way, such that we can, use the data and also the simulation technology to train the robot is the key. So we need to be able to do both imitation learning and reinforcement learning at the same time.
I'll take, just for fun, I'll take the other side. When I think back to going back to the 1980s, AI had a big boom then also, and it was expert systems. And everybody was doing everything AI, and it was all going to be great. And then something bad happened, which is it was sort of an AI winter after that. But something good happened, which is that all the AI people had been thinking about data and the importance of data, and the companies that survived that fall survived because they had learned to do something different. They weren't being so structured with their data anymore. They were able to deal with unstructured data. So I feel like the same thing is going to be true for a little while with humanoids, right? You have humanoids that it's amazing what they can do. At the same time, safety of humanoids is going to be a challenge for a while. They're dynamically stable. I kind of joke, like, what's in common between humanoids and older adults, right? They fall down a lot, they break easily, and they're very expensive to fix. So, we have this problem, and we're going to have this problem for a while because there's a lot of motors in a humanoid by definition, and any motor failing might cause it to fall, and that's going to be a problem. But I also think there's a lot of great stuff coming out of the efforts to build humanoids around people. We have much better motors, much more sort of flexible systems. And so just like in the original, in the 80s AI boom, where a lot of good stuff came out, even though the expert systems wasn't the solution, I think a lot of good stuff is going to come out of the effort to build humanoids, even though I don't know for sure that humanoids are going to be, right now, the solution. Eventually, by the way, AI has taken off quite nicely, but that was 40 years ago. So things take a while.
Okay, going back to industrial automation maybe and away from the humanoids, what are some of the data challenges and opportunities you see in that space, Samir?
It's an interesting question, and I'll build upon what was said. When we think about robots, a couple of things are true. The first one is we don't have enough data, of course, if you want to train them in the same way that we've been training some of our large digital AI models. The second one is safety is absolutely critical. You absolutely do not want your robot to lose power and accidentally smack you in the face, or if it's got legs, fall on your cat or fall on your child. It would be catastrophic. We don't have great ways to address fundamentally the issue of hardware failure in the field or of data paucity. And so when we think about how to make robots useful today, I have a strong bias to being a problem solver, not a tool creator, in a sense that it's very important to me that we take an actual real-world problem and completely solve it. Completely solve it to the degree that people want to use what you've done. It's not a lift for them or a burden for them. And that allows you to have real-world impact, which I think is something that a lot of people care about. So in the real world, to solve a problem completely, and by completely, I really mean completely. Most of the work that people do in AI, is particularly outside industry, is maximum like 20–30% of a solution. And you have to clearly define a problem. For us, those problems have to also be defined in a way that when you go out into the real world, you're bringing robots. For us, living in the high technology world, this is great. For blue-collar workers out in rural parts of the country, it could be an alien artifact like that they might not be too excited about. So you have to find problems that are hard problems that people would welcome a robot doing the work. And you've got to do it in a way that people want to use it. For us, this came down to really looking at stressful, laborious, back-breaking, dirty, difficult, literally bone-crushing and soul-crushing work. And things like loading trucks at 40-degree C, 120 F temperatures in the California desert. Things like standing in a spot, getting a steady stream of little packages and like shuffling them for hours at an end with nothing else in sight. I think if we start there, there's real value by solving real-world problems. People appreciate it. And I think the greatest joy is one time we were at this facility where our robots were sorting goods. There was this lady standing next to the robots, and it's very difficult to get to 100% autonomy. You get to about 80% autonomy, which would mean that in a team of 5, you can have 4 robots and 1 person who might have to come help the robot once in a while. So there was this lady standing there, and I was with a senior executive from the company, and he didn't look at the robot. The first thing he did, he walked to this lady who's a blue-collar worker, and he's like, "Ma'am, how are you doing?" I was like, "Oh, I'm doing great." He's like, "You look at that contraption over there. What do you think?" And I mean, part of me was like, "Oh, it's not a contraption." Yes, it is a contraption. And so she's like, "Well, you know, within our operating facility, this is probably the most boring part of the task. I would much rather be a forklift driver or a conveyor belt technician than be shuffling parcels." And yeah, it kind of does the job. It allows me to take a longer bathroom break, like stuff doesn't get backed up. And I was sweating. I was like, today's the day it's a litmus test. And so I think the litmus test is solve a real world problem, make sure it's solved completely, solve it in a way that people welcome what you're bringing, and just stay in the background.
Fantastic. Okay, we have 1 minute left, so one question starting with Bina that I'd like you all to answer very concisely is: if you had unlimited resources and freedom, what moonshot project in AI and robotics would you pursue to redefine the field? Just super quick.
Oh, a robot to do all the housework, the laundry,
I
dishes,
love that.
everything.
Samir.
I would solve the general decision-making problem, and the way I look at it is you can solve a lot of things with small neural networks. I'm not a big believer in massive neural networks for physical AI. I think there's going to be hundreds of AIs, and the overseer that's like kind of managing your hundreds of AIs to do everything.
All right. Steve.
Baby boomers are turning 80 this year. I'd work on robots that can help us as we age because there's not enough young people to take care of us.
Karen?
I want a universal personal assistant that could do things exactly the way I wanted.
Okay. Thank you all for joining this panel, and thanks everybody for joining us today.